Hello there. I'm glad you've slipped into this little pocket of quiet with me tonight. Somewhere far beyond city lights and weather and clouds, the universe stretches out galaxies, scattered like lanterns in a deep, dark field. We hear about those bright islands of stars all the time. But there's a softer question waiting just beside them. What about the darkness in between? Is it truly empty out there? Or is that darkness holding more than it seems, thin ghosts of atoms, wandering stars, invisible threads of gravity, and something stranger still? Tonight, we'll drift into those in-between places, the vast spaces that most maps leave blank, and see what really lives in the quiet between the galaxies. If this kind of gentle wandering keeps you company, a quiet, like, and a soft subscribe help others find their way here too, only if it feels right. For now, the night is wide, the universe is open, and we'll step into it together, slowly. Out in that wide night, the first thing to notice is how far apart the bright things really are. Photographs of the cosmos can be a little misleading. Long exposures gather light that your eyes could never collect on their own, sprinkling the frame with spirals and soft smudges, as if galaxies were neighbors leaning over a shared fence. It looks almost cozy, like the sky is crowded. But the truth is much roomier and much quieter. Our own home galaxy, the Milky Way, and its nearest large neighbor, Andromeda, are often shown together, two great swirls sharing the same patch of darkness. In reality, the space between them is a gulf so wide that light itself, racing faster than anything we know, takes about 2.5 million years to cross it. The faint haze of Andromeda that touches your eyes on a clear night began its journey long before humans traced stories onto stone. That gentle smudge in the sky is both close, in the sense that it is our companion, and unimaginably far. And even that, by the universe's standards, counts as nearby. Between clusters of galaxies, the distances open up into stretches hundreds of millions of light years across. When astronomers point their instruments into these gaps, they do not find bright stars or busy systems of planets. For long spans of space, there is almost nothing that shines. It is tempting to call these places empty, to imagine them as pure absence. But in science, the word nothing is rarely as simple as it sounds. Even in the loneliest reaches between galaxies, space is threaded with a kind of ghostly presence. There are stray atoms of hydrogen drifting past one another, particles and faint streams of radiation moving through the dark, and the soft afterglow of the universe's beginning still washing silently through. For every cubic meter of that vastness, there may be only one or two lonely atoms. It is a density so delicate that the best laboratory vacuums on Earth would feel crowded by comparison. Yet those few atoms, those thin hints of light and energy, matter deeply. They carry traces of how the universe formed, how it has stretched and cooled, how gravity has sculpted structure from something that once was almost perfectly smooth. The space between galaxies is like a quiet archive where the history of everything has left the faintest fingerprints. If you let your imagination stand in one of these intergalactic regions, the feeling is strange. There is no nearby star to cast a circle of warmth, no planet underfoot, no familiar constellation overhead. Just a darkness so deep it begins to feel like a soft wall around you. The nearest galaxy would appear only as a pale blur, too distant to throw a shadow, too far to feel like a place you could ever reach. You would be held only by the gentle, ever-expanding fabric of space itself. It sounds like the loneliest position in existence, but there is a kind of peace tucked into that thought. Because even here, in what seems like absence, the universe is quietly doing its work. Astronomers sometimes describe the large-scale structure of everything as a kind of foam or web. Galaxies gather along thin filaments, long strands of matter and gravity stretched across unimaginable distances, wrapping around huge, dark regions known as cosmic voids. If you could pull your perspective back far enough to see a truly enormous portion of the universe at once, you would not see galaxies scattered at random. You would see something that looks a little like a three-dimensional spiderweb. Bright knots where filaments meet, long, delicate threads reaching out. Wide, soft pockets in between, where comparatively little resides. The galaxies live mostly at the crossings of those filaments, like clusters of lights where invisible highways intersect. The darkness between those crossings is the in-between, the quiet corridors of the cosmos. It was not always arranged this way. In the very early universe, matter was spread almost evenly. There were tiny ripples, small regions, just a touch denser or thinner than their surroundings, but nothing like the grand structures we see now. Over time, gravity leaned into those differences. Slightly denser patches tugged a little harder, drawing in more matter. Slightly thinner patches lost more and more as their contents were pulled away. Billions of years passed. The rich regions grew richer, building stars, galaxies, and great clusters. The sparse regions grew poorer, becoming the enormous voids that now lie between the bright structures. The result is the cosmic web, vast filaments of galaxies wrapped around bubble-like spaces that span hundreds of millions of light years. To drift through one of those voids, even only in thought, is to enter a place that resists ordinary comparison. The temperature would sit just a few degrees above absolute zero, the coldest possible limit. There would be no air to carry sound, so silence would not just be an absence of noise, it would be a basic condition. Light would arrive only from far away, the faint glow of distant galaxies sprinkled across an otherwise perfect black. And yet, even here, physics hums softly in the background. The entire void is filled with the stretched-out light from the universe's childhood, the cosmic microwave background, the leftover glow from when the cosmos was very young and hot and dense. Over billions of years, the expansion of space has pulled that light into longer, cooler wavelengths, until it has settled into a faint microwave whisper that permeates everything. Too gentle for human eyes, but not too gentle for careful instruments to catch. In that sense, even the deepest void is never truly blank. It carries memory. There is something quietly paradoxical in all of this. The spaces between galaxies are what separate everything, and yet they also connect everything. The same expansion of space that pushes distant galaxies farther apart is not happening in isolated pockets. It is one continuous process, affecting the entire universe at once. When galaxies drift away from one another, they are not flying through some static backdrop. Instead, they are like dots painted on the surface of a balloon as it inflates. The dots do not have to move on their own. The surface between them simply stretches. The more distant the dots, the faster they seem to rush away from each other as the balloon swells. In much the same way, the more distant a galaxy is, the more quickly it appears to be receding from us. Not because it has engines or wings, but because the space in between has grown while the light was on its way. For most of human history, none of this was even suspected. The night sky felt full, crowded with pinpoints of brightness. Only recently did we come to understand that those tiny glittering points are just in our local neighborhood. that the real layout of the cosmos is mostly dark by volume, with galaxies sprinkled sparsely through it like grains of salt on an enormous, invisible table. As our tools grew sharper, we began to realize that these dark stretches might hold the biggest secrets. Two of those secrets now have names that sound almost familiar: dark matter and dark energy. They both came from paying very close attention to what happens in the spaces between. When astronomers studied how galaxies move inside clusters, they noticed something odd. The galaxies were orbiting so quickly that, if only the visible matter were present, the clusters should have flown apart long ago. It was as if an invisible hand were holding them together, adding extra gravity that could not be seen. The idea of dark matter grew from that puzzle, some kind of unseen mass filling space, especially the regions between and around galaxies, binding them with its quiet pull. Whatever dark matter is, it does not glow. It does not shine or reflect light the way ordinary matter does, but it tugs, it shapes. It helps draw galaxies into their filaments, weaving the cosmic web like an invisible framework. If dark matter is the builder and binder, there is also something that acts as a gentle unbuilder, a kind of cosmic loosening. When astronomers measured light from very distant exploding stars late in the 20th century, they expected to find signs that the expansion of the universe was slowing, that gravity was gradually reeling everything back in. Instead, they found the opposite. The expansion is speeding up. To explain that accelerating stretch, scientists use the term dark energy. It might be a property of space itself, a quiet pressure that grows as the universe grows, or some new kind of field that fills every corner of the cosmos. Whatever its true nature, dark energy now seems to dominate the universe's behavior, especially in the vast regions between galaxies, where its influence is not easily outweighed by the gravity of nearby matter. So when we wonder about what lies between galaxies, we are touching the stage where some of the grandest players perform. Dark matter, dark energy, the thin mist of ordinary atoms, and the slow stretching of space-time all do most of their work out there, in the landscapes that look empty at first glance. If you take a telescope and aim it at a piece of sky that appears completely dark to your eyes, and if you let that telescope gather light patiently, something remarkable happens. Pinpricks begin to appear on the image. Shapes emerge. The famous deep views from the Hubble Space Telescope were made this way by staring into what looked like nothing and refusing to look away. From a tiny patch of sky, the telescope collected light from thousands of galaxies, some so far away that their light began traveling toward us more than 13 billion years ago. What seemed like emptiness was, in fact, crowded with islands of stars. But even there, between those distant islands, space vastly outweighed light. Most of the universe, if you measure it by volume rather than by brightness, is made of the in-between, the intergalactic medium, the cosmic web of dark matter and gas, the outward stretch of space-time. These are not just the background, they are the sentence, and galaxies are the punctuation. The bright parts help us read, but the spaces give the story its shape. Letting your thoughts wander through these distances can bring a surprising kind of calm. The numbers are too large to truly picture, the timescales too long to fully feel, and something about that limit takes the pressure off. It is enough to know that the universe is bigger than our worries, that there are regions where almost nothing happens for longer than all of human history, and yet they still quietly support everything that does happen. It is easy, when looking up, to let your attention be caught only by the stars, the bright points, the obvious landmarks. But the more we learn, the more it seems that the darkness deserves just as much attention. The black spaces between the stars on a clear night are not blank. They are hints, little windows into those huge, quiet regions where gravity's whispers and the faint echoes of light are still shaping the future of everything. Galaxies, with all their color and motion, owe their very existence to what surrounds them. Without the quiet gravity of dark matter, the outward easing of expanding space, and the faint, drifting gas that threads the void, there would be no great islands of stars to admire. What once looked like nothing turns out to be the patient architect of almost everything. If, on some future night, you stand beneath a dark sky, let your gaze rest not only on the bright points, but on the velvet that holds them. That darkness isn't an absence to fear. It's a canvas where the universe does its slowest, most careful work, a room made by space itself, so that light, matter, and time have somewhere to unfold. And out in that dark, the universe quietly keeps its balance by spacing things apart. A single galaxy feels enormous when we picture it alone. Billions of stars, rivers of gas. But even if you gathered every star, planet, grain of dust, and wandering atom together, almost everything would still be empty. What the universe contains most of is not matter, but distance. Most of existence is the in-between, the gentle intervals that cradle the bright things. The same is true within us. In sky and in thought alike, it's the spaces between that allow everything else to exist. Those bright islands hardly occupy any of the available space. They are like scattered lamps in a night that is overwhelmingly bare. And even that darkness is not even. In some regions, galaxies cluster together in great chains, forming superclusters that span hundreds of millions of light years. In others, the sky thins out into wide hollows called cosmic voids, where galaxies become rare and far between. The gas there is thinner, the background glow fainter, the average temperature a little lower. If you could drift inside such a region, the nearest galaxy might be just a stubborn dot, no brighter than a distant star that never seems to shift. Still, nothing in this vastness is truly at rest. Galaxies move under gravity's long reach. Within clusters, they fall slowly toward one another along unseen strands of dark matter. Some move together in approaches that last for billions of years, like the Milky Way and Andromeda, already bound to one day merge. Others are carried away from each other so quickly by the expansion of space that no amount of gravity will ever bring them back together. They are like small boats left behind on a tide that keeps rising, the water between them always growing wider. Whenever you imagine these scales, it helps to remember that light itself is finite. Every distant galaxy is not just far away, it is also long ago. The further out we look, the further back in time we are seeing. Some of the faintest smudges ever recorded show the universe as it was only a few 100 million years after its beginning. Their light has traveled for more than 13 billion years, stretched to redder, cooler wavelengths as space expanded around it. By the time that light finally reaches us, the galaxies that sent it may have collided, grown, or faded beyond recognition. What we see is their echo. Between us and those ancient sources lies what looks like almost nothing: thin, cold intergalactic space. Early on, that space was filled more evenly with hydrogen gas, the leftover breath of the Big Bang. With time, much of it flowed into growing knots of gravity and became part of galaxies where it fed newborn stars. Some remained behind, stretched thin between galaxies, warmed and stripped of electrons by the fierce radiation of the first stars and quasars. It is so sparse that a cubic meter may hold only a few atoms. And yet, over enormous distances, that faint presence adds up. Astronomers call this ghostly mixture the intergalactic medium. It still threads the universe today, almost invisible, but not silent. When light from a distant quasar passes through those scattered atoms, a tiny part of it is absorbed at very specific colors. On a spectrum, those losses appear as thin, dark lines that reveal the temperature and composition of the gas the light has crossed. By comparing these fingerprints from many directions, scientists can map out where the unseen matter lies, tracing structures too faint to photograph directly. The result is a picture in which even the emptiest regions are joined by an extremely tenuous network of gas and plasma, a diffuse skeleton on which the visible universe hangs. Where the gas is slightly denser, galaxies grow more easily. Where it is thinner, the great voids stay open. All the while, the stage on which this unfolds is changing too. The universe is not a fixed backdrop with galaxies sliding across it. Space itself is stretching. The rate of that stretching is wrapped up in a number called the Hubble constant, which tells us how quickly distant galaxies appear to recede. Astronomers measure it using nearby stars that pulse like clocks, the faint afterglow of the early universe, and special kinds of supernovae that shine with predictable brightness. Intriguingly, the answers do not line up perfectly. Different approaches give slightly different values, a small mismatch that hints there may be something about the cosmos we do not yet fully grasp. What is clear is that the expansion is not slowing. It is speeding up, as though some quiet pressure built into space itself were pushing everything apart. We call that influence dark energy. Whatever it truly is, its effect is simple. Over time, more and more galaxies will slip so far away that their light will never reach us. They will cross a kind of horizon, not because they are gone, but because the distance between us grows faster than light can close it. In a future so remote it feels more like a thought than a date, the night sky may be almost empty. Most of the galaxies we can see now will have faded beyond reach, carried outward by expanding space. Observers born in that era, living on some gentle world inside a single surviving galaxy, might look out and find only their own island of stars, surrounded by apparent nothing. They would have no easy way to know that. Once, the universe blazed with countless other galaxies. There is a quiet ache in that possibility, but also something tender. The universe is not tuned to our comfort, it simply unfolds. Yet within one small galaxy, in one narrow window of cosmic time, there arose beings able to collect light from across billions of years and use it to reconstruct this wider story. The very act of noticing the spaces between galaxies, of measuring them and wondering about them, is the universe, in a small corner, becoming aware of its own shape. Thinking about these distances does not have to feel lonely. It can be grounding. The gaps between galaxies are not failures or flaws. They are the context that makes everything else possible. Without emptiness, there would be no structure, no outlines, no separate things at all. Space is not just what lies between objects. It is what allows objects to be distinct, to have form, to move around one another, without merging into a single blur. When we look closely at those gigantic separations, we also see how deeply connected everything is. Galaxies that seem alone share the same origin in the hot, dense early universe. They are shaped by the same forces, built from the same basic particles, and tied together, however gently, by gravity's long reach. Across distances so huge that a beam of light takes billions of years to cross them, hydrogen behaves like hydrogen. Gravity pulls as it always has. and the same simple rules describe the fall of an apple and the orbit of a cluster of galaxies. Patterns echo: a spiral storm in a planet's clouds, spiral arms in a galaxy, filaments in drifting mist, filaments in the larger web. The enormous stretches between galaxies do not fracture the universe into separate domains. They help define one continuous whole. The slow widening of space, the way clusters drift apart over billions of years, is part of the same rhythm that governs smaller motions, a long, steady pulse of expansion unfolding for more than 13 billion years. As that rhythm settles in your thoughts, distance starts to feel less like a wall and more like a pause in a piece of music. Between every shining cluster lies the true bulk of the universe, the distance, the dark, the nearly invisible frameworks of matter and light that rarely draw attention to themselves. It is the still stage on which all the bright events take place. When astronomers began to chart galaxies in detail, they started simply: one position, one distance, one faint smear after another marked on a growing map. At first, the pattern looked almost random, like dust scattered on a tabletop. But as surveys widened and deepened, the arrangement sharpened into something more intricate. The points lined up in chains and walls and long bridges. Great knots appeared where many of those lines crossed. Between them, vast holes opened where almost no galaxies shone. From these maps, a picture emerged that we now call the cosmic web. On the largest scales we can see, matter does not spread smoothly. It gathers into a web-like network, galaxies and clusters strung along enormous filaments, with the great voids filling the spaces between. To see how such a pattern arose, it helps to return again in thought to the early universe. Back then, everything was simpler, hot, dense, and nearly uniform. There were no stars or galaxies yet, just a bright, expanding mixture of particles and radiation with tiny imperfections, places that were ever so slightly denser than others. Over immense spans of time, gravity amplified those small differences. Slightly denser spots pulled in more matter, growing heavier and tugging harder, while slightly thinner regions lost material and grew emptier. Computer simulations that start from those first ripples and let gravity run its slow course naturally produce filaments, clusters, and voids, patterns that look strikingly like the ones our telescopes now reveal. Dark matter plays the lead role in this quiet choreography. It does not glow or scatter light, but it outweighs ordinary matter and responds faithfully to gravity. It gathers first, forming extensive halos and long strands. Ordinary matter, gas, and dust, the material that will make stars, falls into those invisible structures and settles into their gravitational wells. In that sense, the visible universe is like a thin, luminous trace of a deeper, unseen design. Galaxies light up where dark matter has quietly piled up. Astronomers have subtle ways to map this hidden scaffolding. One of them uses the bending of light, known as gravitational lensing. When light from a faraway galaxy passes near a mass of dark matter, its path curves slightly, and the image becomes stretched or skewed. By studying these tiny distortions across wide fields of sky, scientists can work backward to reconstruct where the invisible mass must sit. The resulting maps show the same branching web of filaments and knots, the same skeleton that holds clusters together and wraps around the voids. If human eyes could see the cosmic web directly, it might be one of the most breathtaking sights imaginable. A three-dimensional mesh, faintly aglow where galaxies collect along its strands, fading into transparency where the filaments thin into the dark. For all its grandeur, the web is built from astonishing delicacy. The average density of gas in its filaments is far below anything we can reproduce in a laboratory vacuum. A cubic meter might hold only a few atoms, yet spread over such enormous distances, that whisper of matter carries enough mass to steer galaxies, feed star formation, and slowly nourish the giant black holes that sit in galactic centers. When we look deeper, we're really looking back, seeing younger versions of the same vast net. The most distant galaxies we know rest along thin, early filaments, threads just beginning to gather when the universe was very young. Over billions of years, those strands thickened and branched, but the pattern was already present. Letting that sink in softens what empty means. The spaces between galaxies aren't blank pauses where the cosmos stops. They are part of a continuous whole, threaded with matter, memory, and quiet forces. Travel any direction, as far as you like, and you are still moving along some strand of the same design. Within the part of the cosmos we can see, the weave fills everything, and in that weave, even the widest distances have their gentle place. Out along those great strands, something slow and patient unfolds. Dark energy urges space to stretch, and the filaments grow finer, like taffy drawn out by an invisible hand. Galaxies gathered into clusters still feel each other's pull and remain bound, circling in their long dances for ages beyond counting. But between those clusters, the corridors lengthen, the gaps open wider, and the web's rooms grow roomier with time, an expansion that preserves the pattern even as it thins the threads. The pattern will not suddenly vanish. The web's shape will remain, but it will grow more delicate. Bridges of matter between far-flung regions will fade beyond reach, the threads more diffuse, the motions more subdued. In that way, the web is both skeleton and heartbeat, the framework that holds everything in place, and the long, steady rhythm by which the universe thins as it expands. For now, we live in a time when much of this structure is still visible. Telescopes on the ground and in space can still catch the light from distant filaments and the soft glow of gas along them. In some observations, astronomers have begun to see faint wisps of hydrogen stretching between galaxies, like a barely luminous fog tracing invisible lines. Those glimpses confirm what simulations have hinted at for decades. The darkness between galaxies is not truly empty, but laced with delicate material, tying everything together. Even the spaces that look blank belong to a larger pattern, quietly alive in its own gravitational way. When you hold that image in mind, the universe feels more balanced. The bright places, star clouds, nebulae, glowing arms of galaxies are only the embroidery on a deeper design. They can shine where they do because an unseen framework supports them. Without the filaments of dark matter and gas, galaxies would drift like unbound dust in a widening void. Without the hollows of the voids, there would be no contrast to make the clusters stand out. The beauty of the cosmos grows from that interplay. Matter and emptiness, connection and separation, light and shadow. You are not outside that pattern, looking at it from afar. Our own galaxy lies along one of those filaments, connected by gravity to others over distances that barely fit into thought. The atoms in your body were forged in stars, whose lives were guided by the same web. Their fuel was gas that once drifted along those cosmic threads, drawn inward until pressure and heat lit the cores of suns. Every bit of iron in your blood, every trace of calcium in your bones, carries a story that reaches back through supernovae and starbirth, all the way to the early ripples that shaped the web itself. So when you look up at the night sky, it can be soothing to imagine not a scatter of isolated points, but a single, continuous structure. Every star, every galaxy, every fleck of light is part of the same network, bound together by invisible filaments of gravity and time. The dark spaces between are not dead gaps, they are where the threads run. In a universe made mostly of emptiness, it is this web that gives form to the emptiness, that turns distance into structure and quiet randomness into a kind of order. If the web is the framework, the great voids are its open rooms, the wide spaces between the walls. They are the most expansive regions that exist, and also the loneliest. For a long time, the universe was imagined as a fairly even scatter of galaxies. But as maps improved, huge volumes appeared, sometimes hundreds of millions of light-years across, where almost nothing seemed to be. It turned out that these voids dominate the cosmic landscape. Most of the universe's volume is not filled with galaxies at all, but with dark hollows. These hollows are not like the gaps between stars inside a galaxy. Those distances, though vast to us, are modest on cosmic scales. A void is something else, a region where galaxies are truly scarce. There might still be a few, scattered thinly, but they are so far apart that from any one of them, the rest of the universe would look heartbreakingly remote. Some of the largest known voids span hundreds of millions of light-years, while containing only a few dozen galaxies, where ordinarily you might expect tens of thousands. The missing light is so striking that it almost feels like a deliberate pause in the universe's sentence. For a time, no one was sure how such vast spaces could form, but detailed simulations of an expanding universe offered an answer. Regions that begin just a little less dense than average gradually lose matter to their surroundings. Slightly richer areas pull more strongly, drawing material away from thinner neighbors. Over billions of years, the rich get richer. Filaments and clusters grow denser, while underfilled regions are drained, becoming emptier and emptier. The great voids are not mistakes. They are what happens when gravity and expansion work together for a very long time, separating fullness from emptiness until broad walls and deep hollows appear. From the edge of such a void, the view would be simple and profound. In one direction, you would see the crowded side, pale chains of galaxies grouped into clusters, arcing across the dark like distant towns linked by faint roads. Turn the other way, and there would be almost nothing, just blackness rolling outward, with perhaps a single fragile galaxy here or there, each so far away that its light barely whispers against the darkness. It would feel like standing at the last lit shoreline, looking out over a silent sea at night. Inside, the physical conditions push the idea of emptiness close to its limit. The temperature sits only a few degrees above absolute zero, cooled by expansion and the thinning of matter. There is no air to carry sound, no wind, only the faint bath of the cosmic microwave background, the leftover glow from the universe's hot beginning, now stretched into a soft, invisible hum. Yet even here, emptiness is not perfect. Stray atoms of hydrogen and helium drift through, joined by particles of dark matter that ignore light but still feel gravity. In some of the most rarefied regions, a volume that would hold countless trillions of molecules at sea level on Earth might contain only a single atom. If a room were filled with such a vacuum, it could take centuries for that one lonely atom to wander from wall to wall. Those atoms, rare as they are, still matter. They help astronomers trace how gas is funneled along the web and how galaxies at the edges of voids live differently from those in crowded clusters. Galaxies near void boundaries often appear smaller, bluer, and richer in gas, With fewer massive neighbors tugging and colliding with them, they evolve more slowly, forming stars at a gentler pace. It is as though the emptiness around them offers a quieter, more leisurely existence. Deeper inside the voids, where even those borderlands fall away, the occasional galaxy can look strange and alone. Faint, irregular clouds without grand spiral arms, drifting through a night so empty they may never truly encounter another large galaxy. Voids draw interest not only for their quiet drama, but also for what they reveal about the universe as a whole. Because they are so empty of ordinary matter, the expansion of space has relatively free rein inside them. Gravity does less to tug and slow things down, so the effect of cosmic expansion shows more clearly. That makes voids useful test grounds for our ideas about dark energy, dark matter, and the overall geometry of space. The tiny ripples in density recorded in the cosmic microwave background are the seeds from which today's filaments and hollows grew. By comparing those early patterns to the way voids are arranged now, astronomers can follow how structure has unfolded over billions of years, almost like reading growth rings in a tree, only here, the tree is everything, and each ring spans hundreds of millions of light years. In that sense, voids are among the most revealing regions the universe offers. They show what happens when gravity has little to work with and expansion is given time to stretch space almost freely. Where matter is plentiful, gravity gathers and sculpts. Where matter is scarce, expansion writes its own signature, thinning things toward near nothing. The result is a balance, a quiet negotiation between the pull that clumps and the push that spreads, played out over scales far beyond any human horizon. If you could choose a point at random, anywhere in the cosmos, chances are you would find yourself not in the middle of a galaxy, but floating in one of these vast hollows. That is how dominant they are. Galaxies and clusters form the walls and threads that enclose them, gleaming like frost along the edges of a pane. But the spaces inside those outlines make up most of what there is. The luminous parts of the universe, the regions our telescopes so easily fall in love with, are like foam on the surface of a deep, dark sea. There's a gentle irony in what we see. The brightest places, the exceptions are clearest to our eyes, while the rule of things is almost total absence. Yet even that absence is not nothing. It's the negative space that lets the positive shapes appear, the hush that makes a melody distinct. Without the great hollows, the filaments would blur into a uniform fog. Without emptiness, fullness would lose its meaning. Think of those vast rooms, and a quiet acceptance settles in. The voids and the web aren't separate, they define one another. Where matter gathers into strands and clusters, hollows open around them. As expansion stretches space and gravity knits structures, walls sharpen and gaps deepen. Over billions of years, that soft tug-of-war writes the large-scale story, in light and in silence, in what's present and in what's left softly, meaningfully bare. Follow that thought to its widest rooms, and emptiness stops feeling like a flaw. It becomes the space that lets everything else happen. Without long reaches of almost nothing, galaxies would have nowhere to glide, light nowhere to cross, and the universe nowhere to unfold. Motion, change, even the way we keep time, depend on there being room for things to drift and evolve. What feels like silence is simply the stage, steady and generous, so the actors can move. Even in the places that seem most silent, nothing is truly blank. A thin afterglow from the universe's early days still washes through every void, a soft bath of ancient radiation that never quite turns off. Neutrinos, those almost weightless, ghost-like particles, pass through in unthinkable numbers, slipping through galaxies, planets, even our bodies, with hardly a pause. Now and then, a single photon sets off across a vast hollow, traveling undisturbed for billions of years before finally brushing against a telescope mirror. For that photon, the void is not an emptiness to fear. It is simply the long, quiet path home. Sometimes astronomers point their instruments toward a patch of sky and see only darkness and visible light. No stars, no galaxies, nothing that jumps out as a source. But when they listen in other ways, the picture changes. In X-rays, faint whispers of energy from distant quasars slip through. In radio waves, there is a murmur from clouds of intergalactic gas. In gamma rays, brief, sharp echoes of ancient explosions cut across the black. All of it moves easily through the voids, tracing their outlines in colors our eyes cannot see. The emptiest regions are like clear glass, dark but transparent, letting the universe's oldest messages pass almost untouched. On our own scale, even the next star beyond the sun feels impossibly distant. Yet when you set that gap beside the stretches between galaxies, and especially the hollows inside the largest voids, it shrinks to almost nothing. Our whole Milky Way, spinning with hundreds of billions of stars, could fit many times over inside a single giant void and still leave room to spare. These are regions we will never cross in person. They belong to the scale of the universe itself, too large for human travel, too slow to change in ways we could watch unfold. And yet simply knowing they are there changes how the night sky feels. It reminds us that emptiness is not the same as absence, and that space itself is an active part of the story. The great hollows show that even where there is almost no matter, the universe continues to shape itself. Expansion stretches them. Gravity sculpts their edges. Ancient light threads through them, and along their boundaries, galaxies grow, merge, and drift. Their quiet persistence gives meaning to everything brighter. Without broad regions of near-nothingness, there would be no place for the luminous parts to stand out. When you look up and notice the dark gaps between stars, you are seeing a small version of this idea. Those tiny black patches are filled with distance. If you could zoom out far enough, those same kinds of distances would swell into the gulfs between galaxies and then into the enormous cavities of the cosmic voids. The pattern repeats. Points of light scattered across a background of space, on and on, from the scale of a constellation to the scale of the observable universe. For all its flares and collisions, the universe follows simple, steady rules, and even its emptiest places obey them. Gravity, expansion, and time work together like a slow, reliable clock. Galaxies stream around voids like currents, flowing around deep basins in a riverbed, guided by the shape of the unseen terrain. Seen this way, we are not residents of some special, luminous center. We live in the spaces between. Our home galaxy hangs along a modest filament, one thread among many, surrounded on all sides by distance. We look outward into a darkness that is not a blank wall, but a living part of our cosmic address. It is the room that lets galaxies form, breathe, and drift apart. As that picture settles, another layer of the story comes into view, something stranger than the voids, and even more important to the universe's shape. If you were to make a list of everything you can see in the sky, from the brightest galaxy to the faintest wisp of gas, it would feel like a complete inventory. Yet all of that, together, is only a small fraction of what actually exists. Most of the universe is invisible. not because it is hidden behind dust or too faint for our telescopes, but because it does not interact with light at all. This unseen ingredient is called dark matter. The name sounds mysterious, but it is really just straightforward. Dark because it neither glows nor reflects. Matter because it has mass and exerts gravity. What makes it so startling is not only that we cannot see it, but that it appears to be the main framework on which the visible universe hangs. Without dark matter, galaxies would fly apart like sparks from a fire. Their stars would not stay in their graceful spirals and halos. The great web of structure stretching between clusters would unravel. The first hints of this invisible mass surfaced nearly a century ago, when Fritz Zwicky measured how galaxies moved inside a distant cluster and found far too little visible matter to explain their speeds. He suggested that some unseen material must be adding its pull. Decades later, Vera Rubin watched stars orbit within spiral galaxies and discovered that those far from the center were moving just as fast as those near the core. It was as if each galaxy were wrapped in a massive, invisible halo, adding extra gravity in all directions. Galaxy after galaxy showed the same pattern. There was more mass than light alone could explain. The effect does not stop at the scale of individual galaxies. The motion of clusters, the way light from distant sources bends as it passes through them, and the subtle pattern of the early universe's afterglow all point toward the same conclusion. Most of the matter in the cosmos is dark. By our best estimates, roughly 85% of all matter is this unseen kind. The familiar stuff, atoms, stars, planets, gas, and dust, is only a thin surface layer. Even though dark matter does not shine, it has been quietly sculpting the universe from the beginning. When scientists run computer simulations of cosmic evolution and include the effects of dark matter's gravity, something beautiful appears. The dark matter clumps first, forming vast, diffuse halos and long filaments. Regular matter falls into these gravitational wells, cooling and condensing until stars and galaxies ignite. The visible structures we love to photograph are like frost tracing the outlines of an invisible window pane. What dark matter actually is remains an open question. Some ideas imagine heavy, slow to interact particles that rarely collide with ordinary matter. Others picture lighter, more wave-like particles spread gently across space, or tiny black holes born in the universe's first moments. Each possibility carries its own clues, and for decades, experiments have been built to search for them. Deep underground, detectors wait for the tiniest nudge, a dark matter particle brushing against an atomic nucleus. Telescopes on Earth and in orbit watch the sky for faint glimmers that might come from dark matter particles colliding or decaying. So far, every search has come up empty. The silence is striking, but it does not make the evidence for dark matter weaker. If anything, it deepens the mystery. We know something is there from its gravitational footprint, but the thing itself remains hidden. Even without seeing it directly, astronomers have become skilled at mapping where dark matter lies. One of their tools is gravitational lensing. When light from a distant galaxy passes near a massive object, a cluster, a thick filament, a huge dark halo, its path bends slightly. The background image appears subtly stretched or skewed. By measuring those distortions over large fields of sky, scientists can reconstruct the distribution of mass, visible and invisible alike. The resulting maps show a familiar pattern, a cosmic web of filaments linking clusters and wrapping around voids, much of it made of dark matter. Our own Milky Way is surrounded by such a halo, extending far beyond the shining disk. It blends gradually into the larger web that connects us to neighboring galaxies. The stars, planets, and gas we can see are like a thin, luminous slice passing through a much thicker, invisible sphere. The sun, the earth, and every star that crosses our night sky move through this dark sea all the time. We cannot feel it. It leaves no trace on our skin, but its gravity guides the orbits of stars, steers the paths of small galaxies, and helps hold our little group of galaxies together. One of the clearest demonstrations of dark matter's reality comes from watching galaxy clusters collide. In a famous example known as the bullet cluster, two clusters have passed through one another. Their hot gas clouds crashed and slowed, lighting up in X-rays where they piled together. But when scientists mapped the mass in the scene using lensing, most of it was not in the glowing gas. It was offset, lined up with the galaxies themselves. The simplest explanation is that the dark matter halos passed through each other almost unhindered, while the normal matter collided and stuck. In this way, the universe showed us a separation between what shines and what weighs. Dark matter seems to feel only gravity, ignoring light and the other familiar forces almost completely. That aloofness makes it hard to detect and incredibly stable. While stars flare and fade, while galaxies merge and reshape their visible forms, the underlying dark matter web changes only slowly, stretching gently with the expansion of space. It is a quiet, persistent framework. There is an odd comfort in this idea. The cosmos depends on something hidden, something that does not demand attention but quietly keeps everything bound. The bright parts, the stars that warm planets, the nebulae that color telescope images, the arcs of galaxies in deep fields are decorations draped over an unseen scaffold. Here, darkness is structure. It is the very thing that holds the visible world together. Dark matter shares the stage with another great unknown, dark energy, the influence that drives the acceleration of cosmic expansion. One pulls, gathering matter into halos and filaments. The other pushes, urging distant regions apart. Together, they set the rhythm of the universe's growth. Somewhere between attraction and expansion sits the cosmos we observe right now, with galaxies still forming and the web still slowly unfolding. As scientists continue to search for direct signs of dark matter, each new experiment is like a careful hand feeling its way along a darkened room, tracing the outlines of furniture by touch rather than by sight. We may not yet know what dark matter is made of, but we can feel its presence in every rotation curve, every lensing map, every pattern in the early afterglow of the Big Bang. If dark matter could glow even faintly, the night would look nothing like a scatter of points. Overhead, pale filaments would arch and braid, linking every galaxy in a delicate lattice. The empty lanes between would shimmer, revealing the hidden scaffold we now trace only by how it bends light and guides motion. For the moment, the framework stays veiled and speaks chiefly through gravity, from the tight orbits of nearby stars to the slow choreography of the cosmic web. Listening to that pull, we learn that much of what truly matters is not what shines, but what quietly holds. And farther out, past the last bright knots where galaxies taper into gossamer threads, another quiet presence keeps working. Dark energy has no color, no grain, no sound. It does not gather into clouds. It resides in space itself, turning emptiness into something gently active. When we say the universe is expanding faster, we're saying this subtle pressure is edging ahead, in its long conversation with gravity, thinning the filaments, widening the rooms, and letting the hidden scaffold drift outward, even as it still holds the lights in place. Gravity still does everything it can on local scales. It gathers stars into galaxies, galaxies into groups, and groups into clusters. It shapes orbits, drives collisions, and sculpts the familiar spirals and ellipses we see in the night sky. But on the widest scales, where distances run into billions of light years, gravity's influence thins out. There, dark energy's steady push becomes more important than any individual mass. The result is a universe where small regions remain bound together, even as the broad fabric between them stretches ever more quickly. That picture can be hard to hold all at once, so it can help to think in layers. Close to home, nothing feels like it's changing. The distance between you and the ground stays the same. The Earth and the Moon remain in orbit. The planets still circle the Sunday. Our galaxy stars continue their slow paths around its center. On these scales, gravity is strong enough to tie everything together so firmly that dark energy's influence is drowned out. Step 1. Layer out to the space between galaxy clusters, and the balance shifts. Their mutual pull is no longer enough to overcome the overall expansion. The clusters recede, the voids between them widen, and the filaments stretch thinner. Farther still, on truly cosmic distances, dark energy dominates almost completely. Space doesn't just expand, its rate of expansion increases. The farther apart two remote galaxies are, the faster the space between them swells. It is a strange kind of motion because nothing is rushing through anything. There is no wind in this expansion, no preferred direction, no center that everything is fleeing. Every region of space sees every other distant region drifting away. If you lived in some far-off galaxy, looking out at the universe from there, you would see much the same pattern we do from here. A local neighborhood, held together by gravity, and a distant background of systems receding into the dark. In that shared view, dark energy becomes a kind of quiet common ground. It acts the same way in every direction, in every place, at every moment we can measure. It doesn't care whether a region of space is inside a rich cluster, at the edge of a void, or drifting in the middle of an intergalactic gulf. The same faint pressure is present everywhere, adding just a little more distance between far-off points with each passing heartbeat of cosmic time. Because the effect is so uniform, we only notice it when we look across enormous spans and long ages. That's why the evidence for dark energy shows up most clearly in very distant light. The supernovae used to discover it are not nearby stars, but explosions in galaxies billions of light years away. Their faded glow has crossed a universe that was smaller when the light was emitted and larger when it arrived. The tiny mismatch between how bright we expect them to be and how bright they actually appear carries the imprint of accelerated expansion. Other clues come from the way galaxies are spaced, forming subtle ripples in their large-scale distribution, and from the delicate pattern of hot and cold spots in the cosmic microwave background. Each of these acts like a different kind of ruler or clock, and all of them agree, as the universe ages, the expansion is speeding up. Dark energy is doing its work patiently, without pause. It is easy to let these ideas drift into abstraction, to hear the words acceleration and expansion and feel them float away, disconnected from anything familiar, but in a soft way, they touch everything. The fact that the universe expands at all is the reason there was once a time when it was hotter, denser, and simpler. Without expansion, there would have been no cooling, no recombination of particles into atoms, no long age in which stars could ignite and galaxies could grow. The fact that this expansion is accelerating shapes what can happen in the far future. It sets limits on which galaxies will remain in touch, on what kinds of structures can still form, on how far information can travel. Even though you don't feel dark energy when you lift a hand or take a step, the kind of universe you inhabit, the one with long histories and long futures, is written partly by its presence. There is a gentle irony in how much of reality is wrapped up in things we cannot see. The spaces between galaxies, the dark halos of matter holding them together, the energy of the vacuum that pulls them apart, none of these are visible in any ordinary sense. And yet they decide the layout, the tempo, and the eventual shape of everything that does shine. What looks empty is, again and again, revealed as the truly important part. If you picture the universe as a vast piece of music, the galaxies are like notes and chords, bright, brief, and easy to focus on. Dark matter is the structure of the instrument, the wood and strings that let the notes exist. Dark energy is more like the slow change in tempo, the lengthening of the measures as the piece goes on. You rarely notice it in any single moment, but over the span of the entire song, it alters how the music feels. Standing here, on a small world around an ordinary star, in one quiet part of one galaxy, it can be overwhelming to think about all this. The terms dark matter and dark energy can make the universe sound distant and unknowable, as if everything important were hidden behind a veil we'll never lift. But there is another way to hold it. Rather than seeing these ideas as walls, you can think of them as invitations to wonder. We have already learned that we live inside an invisible web of matter that does not shine, that our galaxy rides along filaments stretched between vast voids, that the space between those filaments is not empty, but filled with ancient light and a quiet pressure that slowly grows. We may not know the full story yet, but we know enough to feel the outline of something coherent and continuous. The same laws that guide a falling apple also guide the clustering of galaxies. The same equations that describe how light bends around a nearby star can explain how distant supernovae reveal the universe's acceleration. In that sense, there is no separate set of rules for the grand and the small. Everything is part of a single fabric, from the spaces between atoms to the spaces between clusters of galaxies. As your thoughts move across these scales, from the familiar to the almost unthinkable, you might notice a quiet thread tying them together. The idea that between all the bright, solid things, there is always a field of something softer. Between stars, there is space. Between galaxies, there are voids and filaments and dark scaffolds. Between moments in your own life, there are pauses, silences, and stretches of unremarkable time. Those in-between places, whether cosmic or personal, are easy to overlook. They do not announce themselves, they do not glitter, but they make everything else possible. A universe with no distances, no emptiness, no background energy would be a universe with no motion, no structure, no unfolding story. In much the same way, a life with no quiet intervals would have nowhere for meaning to settle. Thinking about dark matter and dark energy, the hidden web and the quiet expansion can gently shift how you see the night. The darkness between stars stops feeling like a lack and starts feeling like a presence. A calm, patient presence that holds the galaxies in place and carries them outward, slowly, over billions of years. You are part of that motion, just as surely as any cluster or filament. Every second, without any effort from you, the universe is making a little more room. Somewhere in that steady widening, there is room for questions, for curiosity, for the simple act of looking up and wondering what lies between the lights. The answers are not complete yet. They may never be. But the pieces we do have voids, webs, dark matter, dark energy, already tell a story that is both humbling and quietly comforting. That even the emptiest parts of existence are woven into a pattern, and that we, small as we are, live inside that pattern, listening to it unfold. Every moment, without any sound at all, space is making more of itself. Galaxies ride along that change like small leaves on a tide that is always, very gently, rising. The motion is so slow on human scales that it doesn't feel like motion at all. It feels more like a long, steady breath the universe has been taking since its first moments, an inhale that has never quite finished. Through all of this, light is the way we learn what's happening. It has always been our messenger. Every star you've ever seen, every galaxy ever captured in a deep image, every faint shimmer buried in telescope data, each one is a story carried by light. We can't visit those distant places. We can't reach out and touch a galaxy on the other side of the cosmos, but we can catch the photons that left it ages ago and let them tell us where they came from and what they passed along the way. To our eyes, a star is just a point, a tiny glow against the dark. In truth, the light from that star has been traveling, sometimes for years, sometimes for millions or billions of years, before it casually arrives to paint a speck on your vision. The bulb on your desk, the screen in your hand, send out light so young it's barely begun. But the light from the nearest star beyond the sun is already more than 4 years old when it reaches you. The soft haze of the Andromeda Galaxy is light that began its journey when early humans were experimenting with stones and fire. The most distant galaxies we can see sit so far away that their light began moving long before the Earth existed, more than 13 billion years ago. When you look up, you're not just looking away, you're looking back. The night sky is a layered archive of time. The deeper your gaze, the further into the past you are peering. Each photon is a little time traveler, carrying an image of a universe that no longer looks exactly the same. But the path those photons take is not across a rigid stage. Space itself stretches beneath them as they go. Light always moves at the same speed, but the ground it crosses is changing. As the universe expands, each wave of light is gently pulled. Its crests and troughs are stretched farther apart, its wavelength lengthening. To us, that stretching appears as a shift toward the red end of the spectrum, redshift. The light doesn't slow down, but its color ages. A photon that left its home as bright blue or white may arrive to us as deep red or even as invisible infrared. Given enough time and enough expansion, it may slip beyond everything human eyes can see, arriving as a microwave whisper or a faint radio murmur. This is one reason so much of the universe looks dark. The light is still there. It's just been pulled so far from the visible range that our eyes can't catch it anymore. To follow that hidden light, astronomers have built instruments that see deeper than our senses. The James Webb Space Telescope peers into the infrared, catching the stretched glow of very young galaxies. Radio arrays listen for long wavelength whispers from cold gas and distant relics. Satellites, tuned to microwave frequencies, map the oldest light of all the cosmic background glow left from when the universe was young and hot. When you look with these wider eyes, even the darkest patch of sky begins to glow softly. Light also fades, simply because it spreads. Imagine a beam from a flashlight crossing open space. As it travels, it doesn't lose photons, but they fan out, covering more and more area. The farther from the source you stand, the fewer photons reach each square centimeter. A galaxy billions of light years away may still be shining fiercely, but by the time its light reaches our telescopes, only a handful of photons arrive each second. Detectors sit patiently, collecting these few survivors, building up an image from the rare particles that finally reach us after a journey through dust, gas, and the slow widening of space. Even in the great emptiness between galaxies, the path is not perfectly clear. Thin clouds of hydrogen drift there, almost impossibly sparse but not non-existent. Over billions of light years, those scattered atoms can nibble away at certain wavelengths, absorbing and scattering bits of the passing glow. When we break that light into a spectrum, a rainbow stretched out into fine detail, we see tiny bites taken out at very specific colors, forming a delicate pattern called the Lyman alpha forest. Each little notch marks a place where light met gas and gave up a sliver of itself. From those tiny absences, astronomers can map the otherwise invisible gas between galaxies, learning where it lies and how it moves. There was a time when almost all light was trapped in the very early universe, before stars and galaxies. Space was filled with hot, dense hydrogen and helium. Photons bounced endlessly from particle to particle, unable to travel freely. This era is often called the cosmic dark ages, not because there was no light, but because the light could not escape. Only after the universe expanded and cooled enough for atoms to form did light finally break free. Later, when the first stars and galaxies ignited, their radiation ionized much of the remaining hydrogen, clearing the fog even further. It was only then that space became transparent in the way we know it now. The faint afterglow from that transition, the cosmic microwave background, is the oldest light we can see. It left the hot young universe when it was only a few 100,000 years old and has been traveling ever since. Its wavelength stretched by expansion until it's now a cold, gentle microwave bath surrounding us on all sides. Before that moment, there is a horizon we cannot look beyond. Light simply hadn't had the chance to move freely yet, so there is no earlier image for us to see. The part of the cosmos we can observe is defined not by where the universe ends, but by how far light has been able to travel since everything began. Beyond that distance, there may be countless galaxies, clusters, and structures, but their light is still on the way, or has been stretched beyond any form we can detect. As the universe gets older and the expansion accelerates, more and more of that distant light slips beyond our reach. Some regions that are visible to us now will eventually drift so far away and redshift so deeply that their glow fades into undetectable wavelengths. For astronomers, these losses are both a limit and a guide. We will never see the entire universe, but the way light dims, stretches, and bends tells us how it works. The amount of redshift reveals distance and expansion. The pattern of absorption lines reveals gas and structure. The overall dimming shows how far and how long photons have traveled. Even gravitational lensing, the bending of light around massive objects, turns into a tool. A galaxy cluster too distant to see clearly on its own can be magnified by another cluster in front of it, the foreground gravity acting as a natural lens. Sometimes the universe helps us see farther by using its own mass as glass. Still, no matter how clever our instruments become, there will always be a horizon. Some light is hidden behind dust, some swallowed by black holes, some absorbed by gas, and much simply stretched into silence by expansion. In the far future, As dark energy keeps adding space between distant objects, more of the cosmos will glide beyond knowing. The night sky will slowly lose its distant background, not because the galaxies have vanished, but because their light has been carried too far away to be caught. Even then, the photons themselves will go on. Once light leaves a star, it continues unless something stops it. A photon that set out from the first generation of stars is still moving now, threading its way through voids that have grown immensely since its journey began. Whether or not it ever meets an eye or a detector, it keeps its tiny record of where and when it was born. When we imagine the space between galaxies, it's easy to picture a clean, black void, but much of that darkness is simply light we can't see anymore. Ancient radiation cooled and stretched into wavelengths beyond our senses. The universe is bathed in these faint backgrounds. The microwave glow from its early infancy, the infrared warmth from dust in distant galaxies, the low radio sigh of dying stars. Our planet swims through this ocean of soft radiation all the time. Photons from the early universe are slipping through your body right now, unnoticed. If you could see all those wavelengths at once, the sky would never be truly black. It would shimmer faintly, everywhere, with the cooled light of a trillion suns whose names we will never know. The night would feel less like emptiness and more like a quiet room filled with whispers, too soft to hear. Realizing this changes something subtle about what it means to see. We like to think of sight as contact with the present, a direct experience of what is happening now. But in a cosmic sense, seeing is always remembering. Every photon that reaches you is a relic. The further you look, the older the memory. There is no way to see the universe as it is in this exact moment. We can only ever see it as it was. That can feel distant or strangely intimate, depending on how you hold it. Each time you glance at a star, you are catching light that has timed its arrival to this instant, finishing a voyage that began long before you were born. In that quiet meeting between an ancient photon and your eye, distances collapse, the star, the journey, and your brief moment of awareness all touch. Beneath all of this, filling the gaps where light thins and galaxies grow rare, there is something else at work too thin to see, too spread out to feel, but essential to the story. The dark between galaxies is not a perfect vacuum. It is filled with a ghostly mixture of atoms and ions, a soft plasma of hydrogen, helium, and trace elements drifting along the strands of the cosmic web. Astronomers call this the intergalactic medium. It is so diffuse that compared to any chamber we could make on Earth, it would look like pure nothing. Yet it is everywhere, a quiet, invisible presence that threads through the spaces between galaxies and holds, in its own delicate way, another chapter of the universe's history. Far out between galaxies, the intergalactic medium is almost nothing, and yet, quietly, it is almost everything. In a volume of space the size of a room, there might not be a single atom at all. In a cubic meter, there are often only one or two. It sounds like emptiness pushed to its limit. But stretched across billions of light years, that sparseness becomes an immense, invisible ocean of matter, too thin to see, too gentle to feel, but vast beyond anything our minds can easily hold. Astronomers call this ocean the intergalactic medium, or IGM. It is one of the quietest parts of the universe. It doesn't burn like stars or bloom in bright clouds like nebulae. It doesn't collapse into planets or swirl into disks. It simply drifts. And yet this soft background of gas holds most of the universe's ordinary matter, the kind made of protons and neutrons. Galaxies, for all their brilliance, contain only a small fraction of that normal or baryonic matter. The rest floats between them, spread into this enormous, diffuse reservoir. For a long time, that reservoir was invisible. When astronomers added up all the matter they could see in stars, dust, and gas inside galaxies, the tally came up short. The equations describing the universe's evolution predicted more ordinary matter than telescopes could find. It was as if roughly half of the atoms that should have existed had quietly slipped away. This wasn't the puzzle of dark matter. These were regular atoms hiding in the dark between galaxies. Clues appeared when astronomers stopped looking for light coming from the gas and started looking for what the gas did to light passing through it. Distant quasars, brilliant cores of active galaxies, send out torrents of light across the cosmos. On the way to us, that light threads its way through countless patches of intergalactic hydrogen. Each thin cloud absorbs very specific colors, leaving tiny dark notches in the quasar's spectrum. Spread out, that spectrum shows a fine comb of lines, known as the Lyman alpha forest, a delicate barcode recording every encounter the light had with intervening gas. Each line in that forest tells of a separate cloud at a different distance, sitting at a different moment in the universe's history. By reading this pattern, scientists can trace how hydrogen is spread through space and how dense it is from place to place. What they found is that the intergalactic medium is not a smooth mist at all. It follows the same underlying structure as the cosmic web of dark matter, denser along filaments, where galaxies cluster, thinner inside the large voids. Even where there are no shining structures, the gas still remembers the universe's hidden architecture. The composition of this gas carries a quiet story. Most of it is hydrogen, the simplest and most ancient element, made in the first minutes after the Big Bang. A smaller portion is helium, born at the same time. Threaded through that simplicity are tiny traces of heavier elements: oxygen, carbon, nitrogen, iron. Those could not have come from the early universe. They were forged later in the hearts of stars and scattered outward by supernovae and galactic winds. Over billions of years, galaxies have slowly enriched the spaces between them with the ashes of their own lives. Star by star, explosion by explosion, they have seeded the intergalactic medium with metals, sprinkling the great dark with the ingredients for future planets and future suns. Some of that enriched material drifts forever in the wide emptiness. Some eventually falls back in, cooling into clouds and feeding new rounds of star formation. It is a slow circulation, matter out, matter back in, on timescales so long they feel almost still. In this sense, the IGM is like the universe's bloodstream, carrying gas and elements from one region to another, linking galaxies through flows we can only see with careful instruments and patient models. It is thin and quiet, but it is also the medium through which the cosmos shares and reuses its material. The temperature of this gas adds another layer. You might imagine space this empty would be uniformly cold, but the intergalactic medium is surprisingly varied. In some regions, it hovers just above the chill of the cosmic background, only a few degrees above absolute zero. In others, especially along filaments and near massive galaxies and clusters, gravity compresses and shocks the gas, heating it to hundreds of thousands or even millions of degrees. There, the IGM becomes a tenuous plasma, its atoms stripped of electrons and glowing faintly in ultraviolet and X-ray light. Across the whole universe, this creates a kind of temperature map, written in ghostly colors we cannot see. Pockets of warmth lace around clusters and superclusters, while cooler expanses drift in the deeper voids. For decades, detecting that heat was a challenge. The gas was simply too thin to shine brightly. Only with sensitive space-based observatories, tuned to ultraviolet and X-ray wavelengths, did a faint pattern begin to emerge, a diffuse glow tracing the same structures we saw in galaxies, but spread wider and thinner, like a veil. Within this veil lies a particularly important component, the warm, hot intergalactic medium, or WIM. This is the portion of gas heated to between about 100,000 and 10 million degrees. Despite its temperature, it is one of the thinnest substances we know, a few atoms in a cubic meter, sometimes less. Yet, when astronomers accounted for all the mass in this phase, they found that it contained much of the missing ordinary matter their earlier counts had overlooked. The lost atoms were never gone. They had simply taken refuge in a form too subtle to see until our instruments grew sensitive enough. Trying to picture this material in earthly terms is difficult. It is far too rarefied to behave like air, far hotter than any familiar gas, and yet too diffuse to burn or glow in the ways we're used to. It is a plasma, loosened almost to the point of vanishing, a state between being something and almost nothing, and it is everywhere. Every galaxy, including our own, is wrapped in it and floats within it. If you could somehow drift through the IGM without needing air, your senses would tell you nothing. There would be no breeze, no pressure on your skin, no sound. The gas is far too thin to carry vibrations. Yet if you could switch on an impossible pair of eyes tuned to X-rays and ultraviolet light, you would realize you were surrounded by a soft luminosity, faint and uneven. Far away, galaxies would appear as small knots of brightness embedded in a much larger, dim fog of ionized gas. That fog is not static. Along the filaments of the cosmic web, gas slides slowly inward, flowing toward denser knots where galaxies and clusters form. At the same time, galaxies act like small engines, pushing gas back out into the intergalactic medium with winds powered by supernovae or by the furious activity around central black holes. Hot outflows mix with cooler streams falling in, stirring the IGM on scales of millions of light years. Astronomers call this constant exchange the cosmic baryon cycle. Galaxies inhale and exhale matter, drawing it in, turning some of it into stars and planets, then breathing some of it back out, enriched with new elements. The intergalactic medium is the quiet space where that breath spreads and thins, connecting one galaxy's past to another's future. Even if we never see this gas directly with our eyes, its presence shapes how quickly galaxies can grow, how long they can keep forming stars, and how much raw material remains available for new worlds. Computer simulations of the universe's evolution have become detailed enough to show this in motion. In those models, the IGM appears as a delicate, glowing lace, with filaments feeding galaxies and streams of heated gas pouring back out. Over billions of years of simulated time, you can watch matter flow along invisible paths laid down by dark matter, see clouds of gas collide and warm, then get gradually pulled into spinning halos where new stars ignite. It looks almost alive, pulsing and shifting on timescales that our lives are far too short to witness directly. If you imagine yourself floating in the middle of intergalactic space, far from any particular galaxy, it would be easy to think nothing at all is happening. The distances are so great and the motions so slow that, on human scales, everything appears frozen. But if you could compress millions of years into a single breath, you would see faint currents forming, streams of gas drifting along the threads of the web, matter sliding gently toward distant knots of gravity. The IGM would reveal itself as a medium in motion, quietly sculpting the destinies of galaxies that have not yet taken shape. This thin gas is also a record. The patterns of its density and temperature preserve clues about when the first stars lit up and ionized their surroundings, when galaxies began to share their heavy elements with space, and how the cosmic web has changed over billions of years. By studying the intergalactic medium, astronomers are not just learning what lies between galaxies, they are reading a history book written in faint absorption lines and soft X-ray glows. There is something humbling in the way the IGM does its work. It does not stand out. It is the quiet background that makes the foreground possible. Without it, galaxies would be isolated islands, with no way to share or replenish their material. Star formation would sputter and stall. The long, slow cycles of enrichment and renewal would be broken. This nearly invisible medium gives the cosmos continuity, tying distant regions together with nothing more than a few atoms per cubic meter and a great deal of time. Even in the largest voids, where galaxies become rare and the darkness feels deep, traces of this gas remain. The density drops dramatically, but it never truly reaches zero. Space seems unwilling to be completely empty. There is always at least a whisper of matter, a lonely atom here, a stray ion there, a photon passing through. The universe, in all its vastness, behaves less like a collection of separate things and more like a single, continuous whole. Within that whole, another kind of traveler moves through the spaces between galaxies, particles far smaller than atoms, carrying energies that belong more to storms than to dust. While the IGM drifts and flows, these tiny visitors race. The universe may be mostly quiet, but it is never still. Even across the greatest voids, invisible projectiles are in flight, born in places of intense violence and flung outward at nearly the speed of light. We call them cosmic rays. Despite the name, they are not rays of light, but particles, atomic nuclei, solitary protons, electrons, and other fragments accelerated to extreme energies by supernova shock waves, by the magnetic fields around black holes, by the jets of quasars. Compared to their speed, even stars and galaxies are almost motionless. These particles are some of the universe's most restless wanderers, rarely moving in straight, predictable lines. Every second, countless cosmic rays pass through the intergalactic medium, through galaxies, and through worlds like ours. Most will never hit anything solid. They wander for millions or billions of years, their paths bent and rebent by magnetic fields until their original directions are almost completely scrambled. A few intersect a planet and plunge into its atmosphere, striking atoms at high speed and triggering cascades of secondary particles, a brief, invisible rain that falls all the way to the ground. On Earth, this happens constantly. Even as you listen to these words, cosmic ray particles are passing through your body, through the walls around you, through the rock beneath your feet. They are tiny messengers from distant events you will never see, reminders that the spaces between galaxies reach all the way here. For scientists, their energies and compositions carry clues about the places that launched them and about the thin medium they have crossed. Because the gas between galaxies is so thin, it serves both as an open road and as a kind of solitude. Cosmic rays can travel enormous distances without colliding with anything, but once they leave the crowded environments that birthed them, most will never return. Many gradually lose energy as they interact with background light or weak fields, fading into the general hum of radiation. Others cross the entire observable universe and keep going into regions we will never see. In this way, even the empty-looking parts of space are quietly busy. A thin fog of gas, faint fields of ancient light, and rare, high-energy particles all share the same endless corridors between galaxies. The voids are not dead. They are simply vast and slow, filled with presences so subtle that, for most of history, we mistook them for nothing at all. Among all the light that fills the universe, the starlight, the glow of galaxies, the background radiance left from the beginning, there is another kind of light, faint and forgotten, drifting in places where it shouldn't exist. It's not attached to any galaxy or cluster. It doesn't belong to any single system. It floats freely, filling the dark spaces between galaxies with a dim and ghostly glow. Astronomers call it intracluster light, but the name barely captures what it is. These are the traces of orphan stars, the ones that have been stripped from their homes and left to wander the intergalactic medium. They were once part of galaxies, folded into spiral arms or scattered through elliptical halos, circling their centers of gravity like all other suns. Over time, as galaxies fell toward each other inside clusters, tides of gravity pulled at them. Close passes tugged on their outer stars, unspooling them into long, delicate streams. In major collisions, entire swaths of stars were flung out, no longer bound to any single galaxy, but still held by the shared gravity of the cluster as a whole. Those stars don't stop shining just because they've been uprooted. They keep burning quietly where they are, lighting the spaces between galaxies with a glow so faint that it took humanity most of its history to notice it at all. To a telescope, intracluster light looks like a soft haze spreading between the bright cores of galaxies, a smear too smooth to belong to any one system, too dim to see without long, patient exposure. For a long time, this glow was treated as noise, something to be subtracted from images to reveal the real objects of interest. Only when astronomers began to study it deliberately did its meaning start to unfold. The brightness and distribution of intracluster light tell a story about how violently a cluster has evolved, how many collisions it has seen, how many galaxies have passed close enough to tear at each other's stars. In calmer clusters, the intracluster light is weak and patchy, the sign of only a few past encounters. In more tumultuous ones, it forms broad rivers and lakes of faint brightness, evidence that galaxies have interacted again and again, shaking loose countless suns. These orphan stars trace out the paths of old mergers, like footprints left on a dark floor. If you could somehow stand near one of these drifting suns, you might not realize at first that it was homeless. Its light would feel like any other stars, its warmth and color set by its temperature and age. But if you looked outward, the difference would be clear. Instead of a dense field of neighboring stars, you would see great gaps of darkness. The nearest galaxy would hang in the sky as a distant, glowing city of light, not all around you but far away, like a horizon you could never reach. Around you, space would be filled with the same thin intergalactic medium that lies everywhere between galaxies, a few atoms per cubic meter, sometimes hotter, sometimes colder, always quiet. No single world would circle your star, unless by some rare chance a planet had been carried along in the stripping. Most orphan stars are likely bare, stripped of their planetary systems along with their orbits. Yet they keep on burning, fusing hydrogen in their cores, contributing their tiny share to the diffuse light that threads galaxy clusters together. In deep images of clusters, that light is barely more than a suggestion, a few extra counts above the background. But when astronomers stack observations and carefully remove the glare of galaxies, the intracluster glow becomes unmistakable. It is as if the cluster is breathing light into the spaces between its members. These stars are not only curiosities, they carry clues about the mass and shape of clusters, about the strength of their gravitational fields, and about the histories of the galaxies they once belonged to. The amount of intra-cluster light helps astronomers estimate how often galaxies have collided and how much material has been stripped away. In some clusters, as much as a third of all the stars may now live outside of any individual galaxy, adrift, but still bound to the cluster's shared gravity. In that way, the spaces between galaxies are not entirely empty, even in starlight. They contain these scattered suns, drifting like lanterns let loose from their strings. Their presence blurs the boundary between inside a galaxy and outside it. The lines we draw this region belongs to one system, that region to another are human conveniences. The stars follow only gravity's map. There are other sources of faint glow between galaxies too. Hot gas in clusters emits X-rays, forming halos of high-energy light that trace out deep wells of gravity. Radio waves trickle from electrons spiraling through magnetic fields. Together with intra-cluster starlight, these signals sketch a picture of the cluster as one great organism rather than a collection of separate galaxies. Matter, energy, and light are shared, exchanged, and redistributed across the entire structure. If you were drifting in such a region, you would find that the idea of an isolated galaxy starts to dissolve. Galaxies become bright knots inside a larger, softer glow. Between them, the intra-cluster medium gas, plasma, orphan stars, and dark matter fills the space with a kind of low-level presence. Not crowded, not busy in any human sense, but not truly empty either. The stars in intra-cluster light are often old. Many were pulled from the outer regions of galaxies, where earlier generations had had time to age and redden. Their combined glow is therefore warm and diffuse, more like the embers of a long fire than the sharp brilliance of newborn stars. Looking at them is like looking at the memory of a galaxy rather than its current face. Somewhere among them, new stars may still be forming, in places where gas is compressed by collisions or by the motion of galaxies through the cluster's medium. Pockets of higher density can collapse and ignite. Those newborn stars would begin their lives already unbound, citizens of the spaces in between. From their first light, their night sky would be not one galaxy overhead, but many, scattered across the darkness in every direction. Intra-cluster light also helps reveal the shape of gravity where it otherwise hides. When combined with measurements of hot gas and the motion of galaxies, it helps constrain how much dark matter must lie within the cluster to hold everything together. The stars that wander between galaxies trace the contours of the deepest gravitational wells. They go where the potential is lowest, where the cluster's pull is strongest, even if no single galaxy resides there. In this way, the orphan stars become quiet cartographers of the invisible. Their faint distribution draws a sketch of dark matter's unseen landscape, mapping ridges and basins in a terrain made of gravity. Each tiny point of light is both a survivor of past violence and a marker of the present structure that violence helped build. It's gentle to think that even disruption leaves behind something beautiful. Galaxies collide, stars are torn free, orbits are broken, and yet the outcome is a soft, shared glow that binds the cluster visually in a way individual galaxies cannot. The space between them, once imagined as blank, becomes the canvas on which their shared history is painted in the dimmest possible ink. This pattern of light is not confined to the richest clusters. On smaller scales, Between just a few interacting galaxies, similar streams and halos of stars appear. Tidal tails stretch out like faint bridges, arcs of light thrown across intergalactic space. Over time, some of these structures will fade as stars disperse. Others will be folded back in as galaxies merge completely. But for a while, they offer a glimpse of structure in the making, the intermediate states between separate galaxies and a single, larger one. The more carefully we look, the more we find that very little in the universe is sharply separated. Galaxies bleed into their surroundings through stars, gas, radiation, and gravity. The intergalactic medium is not a hard boundary, but a shared environment. Even in the dark gaps, there are remnants, travelers, and echoes. Thinking of it this way, the universe starts to feel less like a collection of isolated islands and more like a continuous sea with local patterns of brightness. The islands, the galaxies, are parts of those patterns, but so are the currents between them, the tides of gas and stars, the windless motion of particles and waves. Some of the intra-cluster stars that wander now will someday end their lives in quiet ways, cooling into white dwarfs that fade almost completely, or in sudden outbursts as supernovae that briefly outshine their entire surroundings. When they explode out in the spaces between galaxies, their light travels unimpeded, crossing the cluster in every direction. Those flashes help seed the intergalactic medium with yet more heavy elements, continuing the slow enrichment of the spaces in between. Even on these lonely paths, the life and death of stars still contribute to the wider story. Their light joins the diffuse glow. Their elements join the gas that will someday fall into another galaxy, another star, another planet. Nothing is truly lost. It is simply redistributed over larger and larger scales. If, on some distant future night, a watcher in another galaxy were to look toward our cluster and take an impossibly deep image, they might see the same thing we see when we look at others: bright galactic cores, veils of hot gas, and a faint, soft web of orphan starlight linking everything together. They would know, without ever visiting, that between those galaxies lies not emptiness, but a shared field of matter and memory. And if you hold that image gently in your thoughts, the dim glow between distant galaxies, the ghostly stars that no longer belong to any single home, it becomes easier to sense how much of the universe's story plays out between things rather than inside them. Not only in the bright centers, but in the faint outskirts, in the thin gas, in the scattered light, in the ripples of gravity and the passing of invisible particles. All of it together, the luminous and the hidden, the galaxies and the gaps, weaves the quiet fabric of the cosmos. The space between galaxies is no longer just a background for the real events. It is where the universe stores its history, carries its connections, and lets its slow, patient transformations unfold, one wandering star and one traveling photon at a time. In the end, when you imagine yourself floating out there, far from any familiar sky, it helps to remember that you would not be outside the universe looking in. You would still be inside its tapestry, surrounded by its threads. The intergalactic dark, the orphaned suns, the drifting gas, the passing particles and waves, they are not decorations added to a finished world. They are the world, as much as any star or planet. To think about what lies between galaxies is to think about the quiet majority of existence, the part that doesn't ask to be seen, yet holds everything else in place with the gentlest of hands. Sometimes when scientists compress data from telescopes into sound, the results surprise even them. The frequencies of galaxy clusters, when translated, become deep, droning tones. The oscillations of stars produce clear, bell-like notes. Each one has its own signature. These aren't sounds the universe makes in air, but portraits of its structure, drawn in a language our ears can understand. They are reminders that behind every image of a nebula or galaxy lies a pattern, a rhythm, a slow repeating motif that has been playing out for millions or billions of years. It's gentle to think of it this way. The universe is not silent because nothing is happening. It is silent because everything is happening in a medium that doesn't use sound at all. Light carries the melodies. Gravity shapes the baseline. Particles like cosmic rays and neutrinos add scattered percussion, tiny impacts you never feel. The intergalactic medium provides the stage, thin and almost invisible, but vast enough to hold the entire performance. Between the galaxies, where our ears would hear absolutely nothing, the score is still unfolding. If you could float out there, far from any world, the quiet would be unlike anything on Earth. No wind, no rustle of leaves, no distant traffic. Your body would make no noise as you moved. The only hints of motion would be what you could see: the slow drift of a galaxy across the black, the faint blink of a distant supernova, the steady, patient glow of orphan stars in a cluster's halo. Inside your own helmet, or inside your own thoughts, you might feel an urge to speak, just to hear something familiar. But the universe around you would not answer in sound. It would answer in light and in gravity, in the soft push of expansion, in the subtle pull of distant masses. In that kind of quiet, the idea of between becomes softer too. The separation we draw between one galaxy and another, between one cluster and the next, feels less like a hard line and more like a gradient. Out in the spaces between, you are not in one place or another. You are simply within the fabric that connects them. The dark you would see isn't a wall. It's a bridge made of invisibly thin gas, old radiation, passing particles, and the gentle curvature of space-time. The more carefully we study that bridge, the more connected everything looks. Light that left a galaxy billions of years ago now crosses the same region as neutrinos from a supernova and gravitational waves from merging black holes. Cosmic rays, born near active black holes, race along magnetic fields that thread the cosmic web. Intra-cluster stars spill their glow into the gaps. The intergalactic medium itself, warmed and stirred by jets and winds, slowly shifts in response. All of these motions overlap without colliding in any ordinary sense. They coexist, layered on top of one another, sharing the same space without crowding it. From our vantage point on a small planet, it can be hard to feel part of this. The scales are too large, the times too long. Yet every photon that reaches your eyes and every particle that passes through your body is a point of contact. You are sitting inside the same universe that galaxies inhabit, bathed in the same background light that has been fading since the cosmos was young. The silence that surrounds those distant structures also surrounds you, just masked by the thin, noisy layer of air and life that clings to our world. If you strip that layer away in your imagination and think of yourself as you really are, an arrangement of atoms held together by forces that work the same everywhere, then the gaps between galaxies feel a little less foreign. The emptiness there is made of the same space-time that flows through you. The photons that cross those voids without resistance are cousins of the light that lets you see a candle or the glow of your screen. The gravity that shapes clusters and webs is the same gravity that keeps your feet on the ground. Between galaxies, none of that is louder. It is just more exposed. There is no atmosphere to muffle light, no clouds to block distant sources, no nearby surfaces to reflect and scatter energy. Everything is direct. A photon leaves a star, and if nothing intercepts it, will travel in a straight line forever, or until the expansion of space stretches it beyond recognition. A gravitational wave leaves a merger and sweeps outward, changing the distance between objects by a tiny fraction as it passes. A neutrino slips through entire clusters without a single interaction, carrying a clean imprint of the event that made it. If you could sense all of this at once, the silence between galaxies would feel dense with activity. You would feel the constant rain of ancient light from the cosmic microwave background, the occasional brighter flashes of supernovae, the deep, slow undulation of gravitational waves, the passage of particles humming through the void. None of it would clang or thunder. It would feel more like a complex pattern of gentle currents, overlapping and passing through one another without ever fully colliding. On nights, when the sky is clear and dark, you already have a small window into that world. When you look up, you see the Milky Way as a pale river of stars. Somewhere beyond that soft band lies Andromeda, and beyond Andromeda, other galaxies too faint for your eyes. Between all of them is the same intergalactic space you've been wandering in thought. You can't see its gas. You can't see its orphan stars or its faint diffuse light. You can't hear its quiet. But the very fact that those distant galaxies are visible at all means that their light has crossed those spaces unhindered to reach you. Every star you see sits not only in its own galaxy, but also within the larger web of existence, connected to every other point by gravity and by the shared expansion of space. The dark between the stars on that sky is not a blank background painted for effect. It is the visible part of an unimaginably large volume, full of very thin matter and very old light. When you let your gaze soften and rest on that darkness instead of on the stars, you are, in a sense, looking at what most of the universe actually is. The more you dwell on that, the more the idea of emptiness changes. Instead of a void, it becomes a kind of room, a space where things can move, evolve, and exist without constant collision. Without the great distances between galaxies, their gravity would tear them apart quickly. Without the low-density gas of the intergalactic medium, there would be no reservoir to feed future generations of stars. Without the calm stretches of nearly empty space, light would have no long corridors in which to carry information from one age to another. Those corridors are why you can know anything about the ancient past of the cosmos at all. Light from the early universe has been traveling through them for more than 13 billion years, redshifted and cooled but still legible. Gravitational waves from mergers long ago still pass through your part of space. Neutrinos from the Big Bang itself continue to stream everywhere, a background as quiet and persistent as the microwave afterglow we can measure. The spaces between galaxies hold these records because they do so little to disturb them. It's tempting sometimes to picture the universe as already written, its grand structures fixed, its future decided by equations. But when you think about those intergalactic spaces, you start to feel how much is still in motion. Gas is still falling along filaments. Clusters are still merging. Dark matter is still drawing invisible scaffolds together. Orphan stars are still being stripped from galaxies, joining the diffuse glow. Black holes are still swallowing matter and launching jets that heat the medium around them. All of it is happening within that same quiet framework of expanding space. Somewhere out there now, a star is being torn from the outskirts of a galaxy by a tidal encounter, beginning its long life as a wanderer. Somewhere else, a pocket of intergalactic gas is cooling just enough to form a small cluster of new stars, born far from any bright spiral or elliptical core. A cosmic ray, launched from a quasar jet millions of years ago, is crossing a void with nothing to slow it down. A gravitational wave is sweeping past a region of near total darkness, stretching and compressing distances by less than the width of an atom, and then moving on. None of these things require an audience. They don't occur so that anyone can see them. They are simply what the universe does when left to follow its own laws. And yet, through a chain of accidents and chemistry and time, one small species on one small world has learned to notice them, to build instruments that collect single photons from galaxies so distant their light is older than our planet, to bury detectors in ice and rock so they can catch a handful of neutrinos among trillions, to hang mirrors in vacuum and measure displacements smaller than atomic nuclei when a gravitational wave passes. In doing that, we have, in a quiet way, joined the conversation that has been going on between galaxies for billions of years. Light has always been talking. Gravity has always been rippling. Particles have always been traveling. Now we are listening, carefully, at the edge of our abilities. We take the faintest possible signals and turn them into images, graphs, and sometimes even sounds, so that our own senses can grasp what our instruments have found. All of this begins with a question as simple and as deep as the one we started with. What lies between galaxies? Not just what objects, what particles, what structures, but what kind of place it is, what role it plays in the story of the cosmos. The answer, as gently as it can be said, is that the between is not an interruption, it is the continuous part. Galaxies are moments of concentration, of brightness and complexity, floating in a medium that holds them, feeds them, and connects them. When you think of it that way, the spaces in your own life can feel a little different too. The pauses between thoughts, the quiet stretches between busy days, the moments when nothing obvious is happening, all of them are still part of the same story. The universe has spent almost all of its existence in what could be called between states, between explosions, between collisions, between births and deaths of stars. Yet those are exactly the conditions that allow structure and meaning to emerge. Out in the dark between galaxies, the cosmos is not waiting for something to happen. It is happening already, slowly, delicately, in ways too subtle for quick glances. Gas flows, light travels, gravity shapes, particles pass, waves ripple, silence holds it all. And from a small, warm planet orbiting an ordinary star, a mind like yours can lean into that silence for a while, let its own thoughts drift apart a little, and simply rest in the idea that even the emptiest spaces are full of connection. You don't have to solve anything or remember every term. It's enough to know that when you look up at the night sky and see the dark between the stars, you are looking at the very fabric that makes everything else possible. The galaxies are the bright punctuation marks. The sentence of the universe is written in the spaces between them, in the quiet, in the distance, in the gentle expansion that goes on whether anyone is watching or not. Somewhere out there, between one cluster and another, a single photon is still on its way from a star that died before Earth formed. Somewhere else, an orphan star is shining into a void so large its light will never reach another world. The intergalactic medium keeps drifting, the cosmic web keeps stretching, and the universe keeps breathing its slow, silent breath. And here you are, sharing a small, calm moment with all of that. letting the vastness settle around you like a dark, soft sky. It's a little odd, isn't it, that when we try to understand the universe, our minds keep reaching for the language of sound. We talk about echoes, waves, hums, harmonies, notes held across distances no lungs could ever fill. Space itself is quiet, and yet our descriptions lean on listening because hearing is how we feel. Continuity. Sight sketches shapes in an instant. Hearing carries a moment across time and lets it breathe. The cosmos, for all its hush, is made of duration, of things unfolding, lasting, fading, returning. Perhaps that is why the metaphors of sound fit so well. Not because there is noise, but because there is tempo. If you could drift through the dark between galaxies, past every bright shore of stars and out into the thin places where matter becomes suggestion, you would not find loneliness. You would find an immense composure. Motions too slow for nerves to notice, light too faint for unassisted eyes, gravity so gentle you would confuse it with absence, yet all of it quietly at work. The silence would not be a void but a medium, the calm within which everything else can happen. And if you could listen with the right kind of attention, you might sense that the quiet itself is a conversation, energy and emptiness trading soft promises, motion and stillness sharing the same long breath. What we call the sound of silence out there is something we cannot hear, but we can understand. It is the even floor under every step, steady enough for light to travel, steady enough for matter to gather, steady enough for time to keep flowing. This background does not carry the story by filling it. It carries the story by getting out of its way and letting it unfold. The calm of space is not indifference. It is hospitality. And as we move through the dark past galaxies, along the faint threads that bind them, through tides of radiation so old they have forgotten the word beginning, the silence comes with us, like a patient companion, not empty, vast, balanced, full of rhythms so soft you need years to hear a single measure. It waits for any listener who can be quiet without needing noise. After traveling so far in imagination, it can feel strange to turn back towards something small, one planet, one lifetime, one human moment. But the human scale is the only vantage we ever hold. Every idea we have about the birth of stars or the bending of time passes through bodies like ours, eyes and hands, instruments we've taught to extend our senses, and the tender machinery of imagination. We are small, yes, but understanding lets smallness reach in ways size cannot. Look up at night, and you meet photons that left their sources before there were humans, before there was an Earth, sometimes before the sun itself was born. You stand on a world orbiting a modest star, tucked inside a spiral arm, nested among hundreds of billions of stars, in a galaxy that is itself one among uncountable others, all laced together by matter we do not see and energy we barely grasp. And yet, the simple act of looking ties you to that immensity. The light that enters your eyes completes journeys measured in ages. You become the last line of an ancient sentence. The human world is scaled to bodies. We measure with strides and outstretched arms, with the span of a day and the patience of a season. We think in hours, not in eons. Even so, the rules that guide a falling apple or a swinging pendulum are the same rules that shepherd galaxies. The gravity that holds you to the ground choreographs the orbits of suns. The thermodynamics that warms a kitchen describes how stars ignite and fade. We are made of the same matter, obey the same laws, share the same unfolding. Small does not mean separate. small is a place within. It is easy to feel swallowed by the cosmic scale, but meaning does not come from size. The universe is vast and also indifferent. Significance grows from awareness, this ability to notice, to ask, to weave measurements into understanding. The cosmos would continue without us. What would vanish is the telling. In that sense, we are the universe discovering it can be known. Consider what a brain is, a thin, rippled architecture of cells and signals, built from atoms forged in old stars. Carbon and oxygen and nitrogen and iron, once drifted in cold clouds, fell toward new fires, condensed, scattered, condensed again, until, here, they arranged themselves into a mind. Every neuron that sparks is the heir to a process that began when the first light escaped the first fog. Thought is a late echo, but it is still part of that first conversation. That is the beautiful contradiction. The universe operates on scales we can barely imagine, and yet the same equations that shape galaxies allow molecules to organize into thought about galaxies. We stand at an intersection between the very small and the very large. Look inward and you meet quanta. Look outward and you meet clusters and voids. Both directions converge on the same mystery. Complexity from simplicity. Structure from the most basic grammar of matter and energy. The numbers we use to map the world strain beyond our instincts. A light year is nearly 10 trillion kilometers. A billion of those is a distance that humbles language. Against such measures, a human life looks shorter than a sigh. And yet, within one life, we have aged the universe, mapped its scaffolding, heard its waves, and sketched the shadow of its darkest hearts. Curiosity, patiently applied, becomes an instrument strong enough to reach what hands cannot. Think of what that means. The atoms in you, arranged into cells and tissues, into a person able to pause and listen, are configured such that they can understand the forces that made them. You can trace yourself backward through families and species, through continents and oceans, through the forging of the earth from dust around a newborn sun, through the collapse of a cloud, all the way to the first few minutes when the lightest elements were written into being. You are, quite literally, made of memory, not in poetry, but in physics. Even with such reach, we live at a human pace. Time moves for us in breaths and heartbeats, in the exchange of light and shadow called day, in the tilt and return of seasons. Cosmic time moves differently. Galaxies weather the ages. Stars spend millions or billions of years practicing their one art. Even light, swiftest of messengers, becomes slow when stretched across the map of everything. A photon may travel for aeons and finish its journey in a blink against an eye. From its perspective, that blink and those aeons are the same moment. So our scale is not wrong or right. It is simply one point along a continuum. We inhabit a middle ground where complexity can flourish, large enough for molecules to meet and bind, small enough for heat and time to foster delicate arrangements. Here, physics becomes chemistry. Chemistry becomes biology. Biology becomes awareness. Telescopes extend our gaze outward, microscopes inward. The same mathematics serves both, the same symmetry and conservation, the same insistence that the world be consistent with itself. When you look at an image of a distant cluster or a faint arch of galaxies magnified by a gravitational lens, you are not seeing with your eye alone. You are seeing with centuries of thought, lenses polished by hands, detectors tuned by equations, orbits calculated by clocks. you are seeing with tools that grew, like you, from a planet's patient day. That smallness is not a limitation. It is an angle of approach. From where we stand, we can see both ways and understand enough to keep going. Our senses are narrow bandpasses through which meaning pours. We see a small slice of light, yet within that slice, the world is painted. We hear a narrow band of frequencies, yet within it, music lives. Experience is finite. Imagination multiplies it. The models we build are bridges between what we can touch and what we can't. In a few thousand years, we stepped from telling stories about lights in the dark to understanding why they burn. We learned that our world is not the center, that our star is not unique, that our galaxy is one among many, that most of what exists is not made of the atoms that make us. Each discovery widens the circle and deepens the mystery. The more we know, the more unknowns we can name. Even what we cannot reach becomes intimate. We cannot travel to another galaxy, but we can submit its light to questions and receive answers. We cannot rewatch the first moments, but we can study the glow they left behind. Knowledge turns distance into closeness, because understanding is a kind of touch. We live at the level where mystery and meaning are comfortable neighbors. Gravity feels constant. The sky curves. A lifetime feels long enough to hold a story. Our instincts are practical, tuned for survival. Our curiosity is open-ended, tuned for wonder. We carry both into the night and let them share the same breath. The questions we ask are simple. The answers they open are wide. Smallness is a posture, not a verdict. From the perspective of an electron, you are vast. From the perspective of a galaxy, you are swift. From the perspective of awareness, you are exactly the size you need to be to hold both images at once. The human scale is where comprehension happens, where the immeasurable becomes measurable enough to enter a mind, where the unknowable becomes knowable enough to be loved. Our units, seconds, meters, kilograms, are inventions, ways to translate what is into terms that hands and voices can share. The universe does not care which tick we call a second. It only demands that our ticks be consistent with what is real. The constancies we discover, the speed of light, the stability of atoms, the reliable dance between cause and effect, make science possible and existence stable. Understanding is incomplete, and still, it is not wrong. Each correction sharpens the picture without breaking what came before. We are not outside looking in. We are inside, made of the same substance we study, thinking with the same rules we write down. Matter has arranged itself into a shape that can reflect on matter. This self-reflection may be the universe's strangest structure, a loop that reads itself and learns. Imagine the universe as a continuum, from the smallest froth to the widest web. Somewhere between is a band where complexity peaks, a place where atoms can last long enough to learn new tricks, where time flows slowly enough for those tricks to accumulate, where the balance of energy is gentle enough to allow a garden. That place is where we live. It is fragile and enduring at once. The universe expanded and cooled and organized itself until such a place was possible. On one small world, complexity woke up, looked around, and began to write. Perhaps that is the special thing about the human scale, not its size, but its relation to everything else. We stand at a crossroads of knowledge and mystery, humble enough to feel awe, sturdy enough to seek. We can look up and meet galaxies beyond counting. We can look into a cell and meet worlds within. The human scale is not apart from the cosmos. It is one of the cosmos's natural outcomes, a momentary expression of its habit of becoming. It is strange to talk so long about the universe and arrive back at a room where someone is lying quietly, hovering between wakefulness and sleep. We have wandered through ages and distances, and the return is simple. You, here, are part of the same story. The forces that guide galaxies are in your bones. The atoms that built stars now keep your heart. The silence that holds clusters apart surrounds you, steady as breath. We asked what lies between galaxies, those gulfs that look like nothing. The answer is not nothing. The spaces are full of light, too thin for naked eyes, matter too spare to touch, energy too even to feel. They are full of expansion and of gravity's soft insistence, full of the fading glow from the first light. The spaces between galaxies are like the spaces between thoughts, never truly empty, always a medium in which connection can pass. Call it stillness if you like, but do not confuse it with sleep. It is a dynamic quiet, a balance that lets everything else exist. Close your eyes, and the darkness is not empty either. It is filled with light, still arriving from everywhere, faint but faithful. Every photon carries a piece of history. Remove the noise of life and machines. Leave the wind and the heartbeat behind, and float in the intergalactic dark. There would be no sound, no echo, but there would be a glow in every direction. The first light, thinned by time. You would be floating in memory. The universe, when all else is stripped away, looks like a sea of old light, slow and calm. It is equally strange and lovely that your breathing belongs to that same continuum. The energy that animates you is not different in kind from the energy that lights a star. The chemistry that keeps you is the chemistry of nebulae, learned under new temperatures and refined by time. Life is one of the universe's experiments in complexity, an arrangement that makes awareness possible. Consciousness is fragile, and yet it can hold a picture that includes both smallness and immensity in one frame. Let that thought soften things. The distance between the personal and the cosmic shrinks when you stop insisting on a border. The universe is not far, it is immediate. The rhythms in you, lungs, heart, the slow drift of warmth echo larger cycles, outside collapse and radiation, gathering and release, expansion and cooling. You were never separate. You only needed reminding. For most of our history, the night has been a mirror. We set stories among the lights and used them to navigate the sea and the seasons. Now we know those lights are other suns, other families of worlds, other towns in the night. Knowing has not made the sky less beautiful. It has made it deeper. Each point is a message from elsewhere and elsewhen. When you look up, you are not just seeing distance, you are seeing time. Some of that light began before Earth formed. Some left before the atoms in you existed. It finishes its crossing in your eyes, ending a story billions of years long. For a brief moment, you are its destination. There is something steadying in that. The universe is vast and unreachable, and also perfectly here. Every atom in you was borrowed from older things, stars and stones, oceans and clouds, and will be lent onward again. You are made of what you admire. There is no magic in that, only physics, and knowing it does not dull the wonder, it clarifies it. The emptiness between galaxies is not just cold distance, it is origin and pathway, field and carrier. It is where light travels and gravity sculpts, and matter decides to gather or to drift. It is the background that makes foreground possible. Right now, whether the sky is clear or clouded, you are under that same structure. You do not have to go anywhere to belong to it. You only have to be quiet enough to notice. When the world softens and your thoughts loosen their grip, the imagined distance between stars and mind narrows. The same calm that balances the wide spaces can fill you. Worries about size and time dissolve into proportion. You do not need to be large to belong to something enormous. You only need to be within it, and you already are. Sleep and the universe are kin in this one way. Both are surrender. In sleep, you let awareness set itself down and drift through an interior landscape without steering. In the universe, matter and energy follow the paths allowed, drifting and gathering, guided but unforced. The cosmos does not strain to exist, it continues. Sleep is that continuation, practiced inside a life. As you drift toward rest, imagine a wider room, not the void as cold and empty, but as connection and warmth shared thinly. All around, light from remote galaxies moves silently, stretched by expansion. Faint hydrogen clouds glow like fog, lit by distant lanterns. An invisible lattice of dark matter holds the pattern together, and you, small, aware, peaceful, float within that balance. You do not have to measure it or explain it. Beauty here is not only in logic, it is in the fact of being. The same laws that hold galaxies hold you. Somewhere, stars are beginning. Somewhere else, stars are ending. The pattern continues, indifferent and exquisite. In this small interval, you belong to it. The spaces are vast, but the distance between them and you is only a thought. The same forces that guide their motion guide yours. Let that be enough. Let the rhythm outside suggest a rhythm within, slow, even, unforced. There is no race here, no need to keep anything from falling. Existence hums on both sides of the skin. If you like, imagine your breath carrying the same steadiness as the universe's widening, gathering, and letting go. Softly, far away, clusters wander apart. Galaxies glide through their shared gravities. The rhythm is the same. The scale is different. Let that thought settle like a light snowfall. The universe is huge, yes, and it is also intimate. You are not other than it. You are its continuity, expressed briefly as a person. So as you let go, think of it as travel, but not a way deeper in. The quiet behind your eyes is the same quiet between galaxies. The calm in your body is the same evenness that keeps the wide things from tearing themselves apart. Every atom, every photon, every drifting world moves inside that balance. You do too. Let the silence widen. Let distances soften. Let light fade into memory. The universe goes on, patient and without hurry. You, balanced between stars and sleep, go on with it. Thank you for lingering in the quiet tonight, through light and shadow, through distance and the soft places between. You have listened across time to a story no voice can finish. And yet, here we are, sharing the same hush, the same moment of being. This is what gentle science is for. A way to let wonder slow down, to let the mind rest inside something larger than thought, to remember that curiosity and calm can share a single breath. If this brought you a little ease, you can return whenever you like. There are always more questions waiting quietly, and we will meet them softly. For now, there is nothing to do. The universe is still here. The stars are still shining. The silence still carries everything forward. Good night, and sleep well under the same sky that began it all.